Welcome to 4B, which is we're identifying key characteristics of quadratic functions. So we're going to be looking at the domain, ranges, zeros, increasing, decreasing intervals, and end behaviors. All right, let's get started. So we're going to first start with 4A, which is graphing. So we'll touch on that quick. So to graph an quadratic, we're going to first do the opposite of B over 2A. So we have our A is 1. Our A is 1, negative 1. Our B is positive 6. That's a weird looking B. And our C is negative 13. Well, you don't need C here. So we have the opposite of B, which is 6. It's going to be negative 6 over 2 times A. So that's negative 6 up top and negative 2 in the denominator. Negative 6 divided by negative 2 is positive 3. So my x value of my graph is of the vertex. So this is finding the vertex, by the way. Now we need to substitute that into the original equation. So y equals negative 3 squared plus 6 times 3. When I substitute, I always put it in parentheses what I substitute. Follow your order of operations. So we got square first. So 3 squared is 9. 6 times 3 is 18, and minus 13. So that'll be negative 9 plus 18 is positive 9. Positive 9 minus 13 is negative 4. So our vertex is at x is 3, and our y is negative 4. Okay, so we have our vertex, 3, negative 4. 3 to the right, down 4. Now we need to go further, and we need to get some more coordinates. So I'm going to draw this is a terrible looking chart, but I'm going to have my chart. In the middle, I'm going to put my vertex, and that's at 3, negative 4. And I'm going to choose 2 coordinates. So looking at my x coordinate, my 3, I'm thinking about a number line. I'm going to go with 1 less than 3 and 1 number more than 3. Now I'm going to go 2 less than 3 and 2 more than 3. So I'm adding 1 each time and subtracting 1. On a quadratic, remember that quadratics are always symmetrical. That the left and right side of a quadratic or parabola are reflections of each other across the vertex. So I'm just going to choose either to do the math on the left or right side. I'm going to choose the 1 and 2. Those are smaller numbers. So I'm going to substitute 1 in to the original equation. So y equals negative 1 squared plus 6 times 1 minus 13. Let's do that math on that. So 1 squared is 1. Opposite of that is negative 1. Plus 6 is, because 6 times 1 is 6. Negative 1 plus 6 is 5. Minus 13 is negative 8. So that means 5 should also be at negative 8. Now let's look at when x equals 2. So 2 squared is 4. Opposite is negative 4. So my first term is negative 4. 6 times 2 is 12. So negative 4 plus 12 is 8. 8 minus 13 is negative 5. So 4 is also at negative 5. So my coordinates are at 2, negative 5, and 4, negative 5, and 5, negative 8, and 1, negative 8. And let's just draw a quick graph, nice U-shaped graph. And now let's go into the characteristics. So domain. Domain is how far left or how far right does the graph go. And in this case, there are no breaks in the graph. It's a continuous graph, meaning I could draw this graph, this U, without picking up my pencil. So how far left does it go? So it keeps going left forever. And how far right will it go? It'll keep going right forever. Left and right, if you're thinking left and right, left is going to negative infinity. Right is going to positive infinity. So how we write this? You can write it as negative infinity to infinity. So parentheses, because they're not, you can never actually include infinity or negative infinity. Or there's another fancy way to write this. It's x such that it's all real numbers. So that's the little backbone of R. That means all real numbers, which is negative infinity to infinity. Those are all real numbers also. All right, range. Range is the y values. So let's do a little highlighter again. So it's range is how low does the graph go? So it's going down, 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 down forever. The right side is also going down, 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 down forever. It'll go down forever. Down forever is negative infinity because it's going down. The highest point it will be is right here. This is the highest point of the graph of the parabola. So that's at -4. So I have negative, so I always start at the bottom, how low to how high. So the bottom, it's going down to negative infinity. And how high will it go? The highest point is at the y values at -4. There's an actual point there on the graph. Like anywhere along the line, there are points. So if you're a part of the graph is there, it's included. So that the bracket means that there's an actual closed point, which is included. All right, find an increasing and decreasing variable or intervals. We need to label. So from left to right, looking at the graph, as you go from left to right on the graph, this is going uphill, so this is increasing, and then it turns, and you're going down, so that's decreasing. So that now we're looking at the domain of each interval. So the red one I have here, that is going how far left? Is going left forever until we get to, what's the x value of this? This is the x value of 3. The y value is -4, but I don't need that. It's always x values for increasing, decreasing. So it's increasing from negative infinity to 3. So you're really just naming the domain of the interval. And then decreasing, it's going to start decreasing also at 3. And it's going to go to the right forever. And right forever is infinity. Now you could use brackets on the 3 and 3's if you want. So you could have brackets here if you'd like. It doesn't really matter to me which one you use. And really, I don't think it matters to most teachers. And if it does, they should explain it. Because there's a couple different ways to explain it mathematically. All right, finding the zeros. Now this is a terrible graph for zeros. 0 means where does the graph cross or touch the x-axis? Well, my highlighted blue line here, which I'll change it to green here, that's where the x-axis is. My graph doesn't ever touch it. It never will. This graph is always going to go down and down, so it's never going to touch it. So it will never cross it. So in this case, there are none. Don't write 0. 0 is a number. End behavior. Now, end behavior, we've got to talk about the ends of the graph. So which directions is the left end going? It is going left slightly and down. How far left will it go? Well, it's an arrow. It'll never stop going left. So it'll go left, and left is, in this case, negative infinity. So it'll go left to negative infinity. And how far down will it go? Well, it's an arrow, and nothing's going to stop it. So it's going to go down to negative infinity. So like a different unit, I'm going to give you this notation, and you have to fill it in. So as x goes to, which is left, x value, goes to negative infinity, the y value goes down to negative infinity. Now on the right side of the graph, which two directions is it going? It's going right, and it's going down. It's going right forever. Right forever is positive infinity. How far down is it going? Well, it's going to go down forever too, to negative infinity. So again, I will give you the notation, and you just have to fill in the blank. So as x goes to the right forever to positive infinity, the y value is going to go down to negative infinity. All right, so you should be able to work through 1, 2, 3, 4, 5, 6, 7. And now I'll show number 8. So 8 is drawing the graph. So I'm going to give you the characteristics and you get to draw it. So what I do first is I look at end behavior first. And I'm looking at the y values. The y values are going down. This means the graph looks something like this, very similar to my last graph, because the y's are going down forever to negative infinity. So my graph's going to be upside down. Then I would look at my zeros. If I have zeros, that's where it's going to cross the x-axis. So 2, 0, my graph is going to cross at 2, 0, and at 6, 0. And I know my graph is upside down. Now I would look at my range. I know my range is going to go from negative infinity, because that's good, because it's going down. And the highest point is going to be at the y values 2. So I know my graph is coming, so we're going somewhere. It's going to be somewhere along here. This line here is where it's going to top out at. I'm going to erase that line because that's not a part of the graph, but that's where it's going to top out at. So this point right here is going to top out at 2. Then I also know that it's increasing and decreasing, and this is x. This is the domain, so we're talking x values. So that's an x value of 4 and an x value of 4. Well, that's up far and left and right. So I know my graph is going to be at 4, and it's going to top out at 2. The 2 is my range, so that gives me a top as 2, and my x values are at 4. So this is at 2, 4. And if you're unsure about this, I would draw a graph and then see if they match up. Domain, how far left does it go? Left forever, right forever. Good. Range, negative infinity, goes down forever to 4, or 2, sorry, 2. Oh, I wrote that wrong. 4, 2, my goodness. It's like, what is going on here? You guys should be yelling at me. 4, 2, sorry. So my range is 2, so the y value is 2. That's my highest point of the graph. Increasing, this is increasing on the left from negative infinity to 4, and it's decreasing from 4 to the right forever. Zeros are at 2 and 6, good, and they both are going down to negative infinity. The ends are both going down to negative infinity. So that's how you draw the graph. So that's what